Okay, so evaluate the following limits. So for the very first one, how do we handle it? I believe at this point you've already watched the video where I've explained the concepts under the limits. If you've not, the link is in the description below. So the limit as x approaches 5, and then we have 2x squared minus 3x plus 4. So each time you're given a question to deal with a limit, just substitute the value you have. Don't only substitute if it's going to give you an error. Now in this case, if we substitute the 5, we're going to have the limit as x approaches 5, and then we're going to have 2, where there's x, we're going to put the 5. Okay, so that's what I've done. Whether we had x, that's where I've substituted this 5. So at this point, 5 squared is 25 times 2 is 50 minus 15 plus a 4. So that's going to be 50 minus 11. That's going to be a 39. Okay, so that's how we simplify the limits. That's how we've done the first one. Okay, let's move. Now if we go to 2, part 2, things begin becoming interesting. Here we have the limit as x approaches negative 2, x to the power 3 plus 2x squared plus 4 over 5 minus 3x. How do we simplify this limit? How do you go about it? So basically, let's try to understand what we can do. Does it have an effect if we're going to substitute the value of negative 2? Okay, so let's try. So where there is x, we're going to put the negative 2 on top, so we're going to have negative 2 to the power 3 plus 2. Where there is x, again we're putting a negative 2. Okay, and then on the bottom, where there is x again, where there is 3x, where there is x, we're going to put a minus 2. Let's see. So at least on the denominator we don't have a 0. On top, what do we have? So negative 2 the power 3 is going to be a minus 8. Negative 2 squared is positive 4 times 2. That's 8. And then we have plus 4. Negative 2 times negative 3 is going to be a positive 6. So 6 plus 5 is 11, right? So this is going to subtract, and then we'll have a 4 over 11 as our result. So the key concept is when you're raising a number, negative 2 to the power 3, it means negative 2 times negative 2 times negative 2. So that gives us a minus 8. Okay, so we just substituted directly because there was no error that we were getting. So with what you've learned, feel free to pause the video and try out the next one. So the third one, here we have the limit as u approaches negative 2. So the square root of u to the power 4 plus 3u plus 6, right? So this is what we have. We have to evaluate the limit as u approaches that. Now the question is, are we going to get any error? Let's substitute. So the limit as u approaches negative 2. So where there's u, we're going to put negative 2. So negative 2 to the power 4 plus 3. And then negative 2 where there's u plus a 6. So what do we have? So negative 2 to the power 4 means negative 2 times negative 2 times negative 2. That's going to be positive 16. Okay. And then that's going to be minus 6 plus a 6. So you notice that 6 will subtract, so you remain with just the 4 as a result. So that's the limit. Simple and straightforward. Simple and straightforward concepts. Now we're on number 4. Number 4, here the limit as x approaches 2, x squared plus x minus 6 over x minus 2. Now this is a part where if you substitute a 2 where there's x, you begin to have the denominator now becoming a 0, which makes the whole expression to be undefined. So at this point, what we usually do is ensure you factorize. Okay, So x squared plus x minus 6, that can be expressed as its factors. So let's look at what we have. The product is 1 times negative 6. So the product is negative 6. The sum is the coefficient of the middle part, which is a 1. What two numbers can you multiply to give you negative 6? You add them, they give you 1. So that should be 3 and a 2. So negative 2. So that it will give us a negative 6, and then when you add, we get a positive 1. So if you've got a coefficient of a 1, then you're going to have just x plus 3 and x minus 2, since these are your factors. So we'll just add x. This only applies when the coefficient is a 1 of x squared. If not, then just substitute on the middle part with 3x and minus 2x. And then group them, and then factor out, you still get the same result anyway. So at this point, this is reducing to the limit as x approaches 2. We've expanded it to x plus 3, x minus 2. That's for the numerator. The denominator is 2x minus 2. So we're trying to do away with x minus 2 because it's making the denominator to be undefined. So we can divide, and then we remain with the limit as x approaches 2. And then we just have like x plus 3. So at this point, you know, when you plug in a 2 there, you're going to get the 5. So that's the limit, right? Simple and straightforward. Now we'll proceed. We're on the next one now. So the limit as t approaches 5, and then you have x minus 5 over x squared minus 25. So how do you handle this one? So equally this one, if you're going to substitute in the t, I think this is an error. So you can't have a t and then we're having x. So let's just say it's x. So x approaches 5. So you're going to see that you're going to get a 0 over a 0. This is undefined. So equally here we're supposed to, here we apply a difference of 2 squares, since we know the limit as x approaches 5. For the top part we have x minus 5. The denominator we have x squared minus 25. So that can be expressed as 25 is the same as 5 to the power 2. And then we have the limit as x approaches 5. So a difference of 2 squares implies you can come up with 2 of them and then just change the sign. So we can have x minus 5 and then also x plus 5. That's what a difference of 2 squares is called. So even in a case where you have x squared minus 1, it can still be expressed as x squared minus 1 squared. And then as a difference of 2 squares, you can have x minus 1 and then also x plus 1. Very important. So you can clearly see equally here you can divide, so on top you're going to remain with a 1. And so therefore you have the limit as x approaches 5, 1 over x plus 5. So if you put a 5, you're going to have 1 over a 10 as your solution. Okay. So we were done with number 5. The next one. So how do you determine the limit as x approaches 7, root of x plus 2 plus 3 over x minus 7? Now this is a very funny question. Why? Because if you're going to plug in again there, it's going to be an issue. Now feel free to pause the video and try it out. Now you will notice that this one is different in that you can't factorize what is on top. You can't factorize what is on top. So there is no way you're going to cancel out this part. Okay? There is no way you're going to cancel it out. You can try to multiply by the changing the sign, everything. This is not a sad, so still it won't work. So we'll just apply L'Hopital's rule, which tells us that if you're going to have something like this, if you differentiate the top part and the bottom part, try if it's going to work. So let's try to differentiate the numerator and the denominator. So for the numerator, what's the derivative of what we have? So the expression we have is like x plus 2. Square root is the same as the power half plus a 3. So how do you differentiate that? So the derivative there is going to be, we're going to apply the chain rule. So 1 times half is half. Reduce the power by 1, it becomes negative half. The constant will disappear. So whenever you've got a negative power, you can take it to a denominator so that it becomes a positive power. So you have x plus 2, the power half. Now you know that half is the same as the square root, so it's going to be 2 root of x plus 2. That's for the top part, so we have the limit as x approaches 7. So after differentiating the top part, you have 1 over 2 root of x plus 2. Now for the denominator, what's the derivative of x minus 7? So it will just be a 1. Now you notice that the 1 basically doesn't have any difference. So ultimately all we have is just this part remaining anyway. So at this point we're at liberty of substituting. That's if it's not going to be undefined. So we're going to have 1 over 2 root of, where is x, we're going to put a 7 plus 2. So we have 1 over 2 root of 9. So we have 1 over root of 9 is 3. So 2 times 3. So you end up with 1 over 6 as the limit for this beautiful question. Okay, let's move on. With what we've learned so far, feel very free to pause the video and just try out the next question. So how do you handle the limit as x approaches negative 4 for x squared plus 5x plus 4 over x squared plus 3x minus 4? How do you handle this one? So obviously, to make things easier, we are just going to factorize in advance even before trying out anything. So it's possible we may get a 0. Let's try the denominator. The denominator is going to be negative 4 squared plus 3 times negative 4 minus 4. So this is going to be a 16. That's going to be a minus 12 minus 4. So this is actually a 0. So we can't just substitute directly. So let's try to factorize what we have. So the first one, the numerator is x squared plus 5x plus 4. The product here is a 4. The sum is a 5. Think of two numbers that you can basically multiply to give you a 4. You add them, they give you a 5. So basically we have 1 and a 4. 1 times 4 is a 4. 1 plus 4 is 5. So whenever you've got a coefficient of 1, so you're going to have x plus 1 and then x plus 4 directly. Okay, so the limit as x approaches negative 4. So for the top part we have x plus 1, x plus 4. We can look at the denominator. Feel free to pause the video and factorize it. So we have x squared plus 3x minus 4. What's the product? The product here is a minus 4. The sum here is a 3. So the product, multiply the coefficient of x squared and the constant, and then the sum, get the coefficient of x. So what two numbers can you multiply to give you negative 4? You add them, they give you a positive 3. So obviously that would be a 4 and a negative 1. 4 times negative 1 is negative 4. 4 plus negative 1 is positive 3. So we've got the coefficient of 1, so it's just going to be x plus 4, x minus 1. So x plus 4, x minus 1. So don't forget we were dividing them. So we factorized both the denominator and the numerator. So we can see that can divide. So we have the limit as x approaches negative 4. We're remaining with x plus 1 over x minus 1. And then we can beautifully substitute. So on top you're going to have negative 4 plus a 1. Negative 4 minus a 1. That's going to be a minus 3 on top. On the bottom that's a minus 5. So that gives us 3 over 5 as a solution. Interesting, right? Simple and straightforward. be at liberty of pausing and trying out this next question. The limit as x approaches 2, you have x squared plus x minus 6 over x minus 2 raised to the power 3. Okay. So how do you look at this one? What are we supposed to do? If we're going to go with direct substitution, you notice that the denominator is going to be a 0. So let's try to prevent that. So looking at what we have on top, we have a quadratic, so we should be able to factorize that. X squared plus x minus 6. The product here is negative 6. The sum is 1. Factors, what two numbers can you multiply to give you negative 6? You had them give you 1. Should be a 3 and a 2. Now for us to have a positive sum, it means negative 2 is supposed to be there so that we have a bigger positive number. 3 times negative 2 is negative 6. 3 minus 2 is 1. So therefore, after factorizing, you're going to have x plus 3, x minus 2. So what do we have? So we have a limit as x approaches 2, and then you have x plus 3, and then x minus 2 over x minus 2. All this is raised to the power 3. So this and that will divide. So the denominator, which was reading to a 0, has finally been dealt with. So at this point, what we're remaining with is we're remaining with the limit as x approaches 2. Numerator, we have x plus 3 as the only remaining part. Everything else has been cancelled. So plug in a 2. You're going to have 2 plus 3 raised to the power 3. 5 to the power 3. 5 times 5 is 25 times 5 is 125, is it? Okay, so that's what we have as a result there. We are now on question, should be 9. So you are still at liberty of pausing the video. So you have got the limit as h approaches 0 for the square root of 1 plus h minus 1 over h. So here we're now having SADs. Okay, we'll apply the concept of the conjugates here. You know that if you're going to plug in a 0 for h, it's going to be a 0. You can't divide by a 0. So we can avoid this by actually multiplying by the conjugate of the numerator. The conjugate implies we change the sign. So I have 1 plus h, we change the sign in between so that we have plus a 1. Whatever you do to the numerator should be done to the denominator. So this applies even if we had done h on top. You could basically do this. Let's see. So whenever I'm multiplying a conjugate and a SAD, this applies even to complex numbers. Just multiply the like parts. This times that, the brackets basically are going to disappear. So you're going to just have 1 plus h. Negative 1 times 1 is going to be a minus 1. On the bottom, we'll not simplify anything. We'll leave them as they are. Product of h plus 1 plus h plus a 1. Okay. At this point, 1 and the minus 1 are going to subtract. So remain with the limit as h approaches 0. And then you have h over h. Let me basically show this on the next step better off, so that you can clearly see what I'm writing. So what we have here is the limit as h approaches 0. We have h over h. And then in the brackets we have 1 plus h plus a 1. So the h can divide clearly. So therefore you have 1 over root of 1 plus h. So obviously h, you can plug in a 0 at this point, plus a 1. So therefore what you have is 1 over root of 1 is a 1, plus 1, so that's a 2. So I have 1 over 2 as the result. So just multiply by the conjugate. I think at this point you should be able to answer the next question without any challenges. The limit as x approaches 2, and then you have x to the power 4 minus 16 over x minus 2. So here what we have is the limit. Okay. What you can see is if we're going to substitute directly into the denominator, basically what you're going to see, is you see that we have a 0 in the denominator. So at this point, this I believe we can write it as the limit as x approaches 2, and then we have x to the power 4. 16 can be expressed as 2 to the power 4, right? Over x minus 2. Okay. Now here the question is, can we factorize the, are we able to factorize the x minus 2 so that we cancel it out? Okay. So that we cancel it out. So I think I would apply other concepts like synthetic division. Yeah, let's try synthetic division. So we are dividing x minus 2. So x minus 2, if we are equate it to 0, we'll find that x should be equal to 2. So for synthetic, what you do is you write down your 2 somewhere this side, draw a line, write the coefficients of whatever you have. So here we have x to the power 4, right? So it's down. So I have x to the power 4. So a coefficient of x to the power 4 is just what? A 0. Oh, it's a 1. So 1. And then x to the power 3, we don't have anything. X to the power 2, we don't have anything. X to the power 1, don't have anything. Not until minus 16. So all these will be assumed to have coefficients of zeros. So 0, 0, 0, and then finally we have the constant. So what you do is for the first one, just put it down, and then you'll be multiplying by the 2 now. 2 times 1 is a 2, plus 0 is a 2, 4 plus 0 is a 4, that's 8, that's now 8, so that's now 16, remainder 0. So at that point, what you have after dividing is this. So since we had started with the power 4, this will be the power 3, the power 2, the power 1, and the power 0 as a constant. So what we have after dividing is x to the power 3, 2x squared, plus 4x, plus 8. You can use long division if you want. So what we have the limit as x approaches 2. For the top part, after dividing by x minus 2, which was x is equal to 2, we are getting x to the power 3 plus 2x squared plus 4x plus 8. And for sure, if you are going to divide these, if you are going to multiply the 2, you are basically going to end up with what we had, this one. So x minus 2. So at this point, this is now able to divide, and we can just plug in a 2 for the remaining part. So we have 2 to the power 3, 2 to the power 2, 4 multiplied by 2 plus 8. So 2 to the power 3 is 8. 2 squared is 4 times 2, that is 8 again. This is 8 again. That is 8 again. So the question is 8 times 2 is 16 times 2 is 32. So that's how we handle this question. Simple and straightforward. So we're now on question number 11. So you have the limit as x approaches -4. Then you have 1 over 4 plus 1 over x over 4 plus x. So how do you handle this one? So what do? We'll take a step. Let's try to deal with a numerator. Since we've got fractions, I think we can come up with a common denominator there. Why are we not substituting directly? If we plug in a negative 4 as x, we're going to get a 0 on the denominator. So we are trying to avoid that. We're trying to try other ways of dealing with it. So we can come up with a common denominator for the top part. So that can be 4 times x, which is 4x. 4 into 4x is going to be x. X into 4x is going to be a 4. So we know that after multiplying by the ones that are numerators, there will be no difference. So that's why we're just maintaining x and 4. Bottom, we just have 4 plus x. Okay, so that can be written as, of course, don't omit the limit as I have. Yeah, don't just omit it. So at that point, what we have is like the limit as x approaches negative 4. Now it's like we have x plus 4 over 4x, and then we're dividing by 4 plus x. So dividing by something is as good as multiplying by the reciprocal. So that's as good as multiplying by 1 over 4 plus x. So which will just give us the limit as x approaches negative 4. For the denominator, we're just going to have 4x multiplied by 4 plus x. The top part, we have x plus 4. Okay. So x plus 4 and 4 plus x are just the same. They can cancel, can divide. So we have the limit as x approaches negative 4. And then on the top part, we have the 1, bottom we have 4x. You can substitute. So I have is, if an x, we're going to put a negative 4. So you end up with 1 over 16. So it's negative 1 over 16. Okay. That's where we've ended for this question. So there are a lot of ways, as you've seen from the questions we've attempted, there are a lot of ways of you trying to avoid a negative denominator. There are a lot of ways. Now let's look at question 12. Here we have the limit as t approaches 0, and then you have 1 over t minus 1 over t squared plus t. Now this question is very funny because if you try to substitute where we have t, you're going to have denominators of 0, 1 over 0 minus 1 over 0, so we can't simplify those ones. Okay, so what can we do? So let's try to combine them. Let's try to subtract. We see what we're going to have. So 1 over t. Now the other part, if I factorize out a t, I'm going to have t plus a 1. Okay, so just trying to show you that if I'm going to come up with a common denominator there, it means t plus 1 is a common denominator. So if I'm going to divide by t, I'm going to remain with t plus 1. And then if I'm going to divide by the whole thing, I'm just going to remain with minus 1. So we have limit as t approaches 0. So I've just performed basic algebra here. And so what remains, we have the limit as t approaches 0. For the top part, only a t will remain. And then the bottom, we have a t and then t plus 1. So we have the limit as t approaches 0. So t over t and then t plus 1. So this can divide. So you now have the limit as t approaches 0, 1 over t plus 1. And then you can gradually substitute. You're going to have 1 over, where there's a t 0 plus 1, so it's the 1. So you just have the 1 as the result. Okay, and then finally the last question under part 1, to do with these basic limits, we have the limit as x approaches 0, then you have x over root of 1 plus 3x, okay, and then minus a 1, separatory, not under the square root. So here you see, I gave you an example of question this one, question 9. I said even if it's on top, it's basically the same concept. So you know, if you substitute, you're going to have a 0 on top. So as a good practice, multiply by the conjugate. So 1 plus 3x plus 1 . So what you're going to remain with, by the way, feel free to pause the video and try this one out on your own. So the numerator going to remain with x multiplied by 1 plus 3x and then plus a 1. Denominator, you're going to have 1 plus 3x. Since when you multiply the like parts, the square root will go. And then negative 1 times 1 is just going to be minus 1. Right? So at this point, you have the limit as x approaches 0. So for the top part, you have x and then root of 1 plus 3x plus a 1. So on the bottom, 1 and 1 can subtract. So you only remain with a 3x there. So for the 3x, the x and the x can divide. So that you just remain with a limit as x approaches 0. And then you remain with what's in the brackets. So that's 1 plus 3x plus a 1 over a 3. You can gradually substitute the value of 0. So that part will be eliminated. We have a root of 1, which is just going to be like a 1. 1 plus a 1 is going to be a 2 over a 3 as our result or our solution to that limit. Yeah. So this is where question 1 ends. Okay. Alright, so we'll continue with question 2. Here we're trying to evaluate the limits that involves the infinity. So first one, the limit as x approaches infinity is what we're trying to look at. And then you have x squared minus 1 over x squared plus 1. So the basic idea that you need to know, and that I believe you've already learned under our discussion, you know that the limit as x approaches infinity, whether infinity or negative infinity, if it's 1 over x or any power of n, this you should know that it's equal to a 0. Why? You can actually try to observe this as you try to increase. If you're going to start from, let's say, 10, try 100, try 1,000, try a million. So you see that as you begin to increase the numbers below there, what do you begin to see? You begin to see that the value is going to be getting closer and closer to 0. So that's what it means. And this is actually true if you try to sketch a graph of any function in that form of 1 over x. Alright, so when you're given a fraction like this one, what you basically do is you need to divide by the highest power. Okay, highest power on both the denominator and the numerator. So this implies that on our next step, we're going to have the same limit as x approaches infinity. So if you check the numerator, what's the highest power? It is x squared. So divide by x squared. So we have x squared divided by x squared minus 1 over x squared. For the denominator, the highest power is also x squared. So divide the entire denominator by x squared. So after we've done that, on our next stage, you say that you're going to remain with x as x approaches infinity. The limit as x approaches infinity. Divide that, you have a 1. Then the other part, you also have a 1, but plus 1 over x squared. So at this point, you're now able to distribute the limit. Okay? So you remain with 1 minus. So where we have the x, that's where we're going to distribute the limit. So 1 over x squared, and then over 1 plus the limit as x approaches 0 for 1 over x squared. So I told you to say, if you're going to have 1 over x and then you've got x approaching infinity, not 0, you understand that they are all going to be equal to 0. So you're going to have 1 minus 0 plus over 1 plus 0. So at the end of it all, you're going to have 1 divided by 1, which just gives us a 1. So the basic idea is the limit as x approaches infinity or negative infinity in the form of 1 over x or x to any power, the answer is a 0. Okay, so that concept is very important and it will help you. It will help you in simplifying. So let's try to see what we can do for the other three. Feel free to pause the video and apply the same concept to the next question. So here we have the limit as x approaches infinity, and then we have 4x squared minus x minus 2 over 5x squared plus 4x plus 1. So for your information, for people in a case where you have run out of time, just know that whenever you're trying to determine the limit of polynomials being divided, it's just get the coefficients of the highest powers. So coefficient on top is 4, on the bottom it's 5. So that would be your answer at the end of it all. Okay? So you understand that what you're going to do is you divide by the highest power, right? So the limit as x approaches infinity, don't forget our answer, our predicted answer is 4 over 5. So for the top part, you divide by x squared throughout. So you're going to have 4x squared divided by x squared minus x divided by x squared minus 2 divided by x squared. We're dividing by the x attached to the first one. And then for the bottom, 5x squared. So the highest is x squared, so divide by x squared throughout. X squared, x squared. So you remain with the limit as x approaches infinity. So that will cancel. So you remain with a 4 minus 1 over x minus 2 over x squared. There we have a 5 plus 4 over x squared plus 1 over x squared. So you understand that there's this point. This is a point we are going to distribute this now. So every part that is having x as a denominator is going to be a 0. And so at the end of it, we are going to have 4 over 5. I told you how to distribute in the previous example, so you can show that. So equally for the third one, you do the same. Here we have the limit as x approaches, this is t, as t approaches negative infinity. And then you have t squared plus 2 over t to the power 3 plus t squared minus 2. So for this one, we'll do the same. The limit as t approaches negative infinity, we'll divide by the highest power on top, it's t squared itself. So it will be t squared plus 2. So divide by t squared divided by. So for the bottom, we divide by the highest power, which is t to the power 3. So t to the power 3, t to the power 3, t to the power 3. So what we have? So I'll just go. The limit as t approaches negative infinity. So on top, divide. So you have 1 plus 2 over t squared. Denominator you have that will divide. So you have 1 plus 1 over t. And then that's a minus 2 over t to the power 3. So all the parts that are having a denominator of a t will become zeros. So eventually just remain with a 1. This is very important. Now we have an interesting one, that's the fourth one, which is dealing with a radical. The limit as x approaches infinity, x plus 2 root of 9x squared plus 1. So apply the same concept of dividing by the highest power, including under the denominator or under the square root. So you're going to have the limit as x approaches infinity. So you have on top divided by x, you have x over x plus 2 over x. Denominator you're going to have the square root. Now we divide by x squared. X squared 1 over x squared. So we have the limit as x approaches infinity. So this is going to be a 1, so 1 plus 2 over x, and then square root of 9 plus 1 over x squared. So you can distribute now the limit. So every part where we have x as a denominator, it will be 0. So we have 1 on top remaining, on the bottom you have root of 9 remaining, which will eventually be 1 over 3 as a result. Simple and straightforward, right?